So let's begin our look back by reviewing question number 2, in which you're asked to simplify this expression and to make sure to use only positive exponents in writing your answer. This is a classic. There's a lot of exponent arithmetic going on in this problem. So the hardest part is keeping it all straight and answering for yourself the question, when am I going to add exponents? When am I going to subtract exponents? When am I going to multiply exponents? If you can keep the answers to those 3 questions straight, then you'll have a pathway to work through this problem. So looking at what's here, what do you want to do first? What is your instinct here as to...
You multiply everything to the third.
Yeah, so what you're doing there is you're looking at this quantity that's in these parentheses and focusing on the fact that there's an exponent attached to that quantity. According to the order of operations, we have to contend with that exponent first before we do anything else. That exponent has to come before the multiplication, which happens right there in between these 2 terms. Right? So we've got to handle the exponent first. And handling the exponent means distributing it across all the multiplication and all the division that happens inside the parentheses. So that power has to be applied to every single factor that's inside the parentheses. Including the other exponents. Right, so if I want to add in an intermediate step here, what I end up with is 3 raised to that power, multiplied by u to the minus 2 raised to that power, multiplied by v raised to that power, all of that then divided by w to the minus 2 raised to that power. So that third power has applied to every factor present inside the parentheses. And then we'll have some simplification to do, but I'm going to quickly also just add on the rest of the stuff that's out on the front here, just so that we make sure we don't forget it.
And a quick question, why the 3?
It's a very common error to think of the 3 and the u that are right here as being part of the same factor, when in fact, according to the order of operations, this u has 2 things attached to it, a multiplication by 3 and an exponent of negative 2. And the order of operations says that that exponent has to happen first. So what's being raised to the negative 2 power in this expression is not 3u, but just u. And that multiplication by 3 happens afterwards. So from the point of view of breaking this expression into separate factors, we have 3 separate factors upstairs here. A 3, a u to the power minus 2, because the power attaches just to the variable, the base that's next to it, and then also a v. So that when we distribute the exponent, that exponent distributes to each one of those 3 factors. The 3, which people often forget to raise to the third power in this example, the u to the minus 2, and the v. But yes, that's such a common place for people to get steered astray that it pays to be hyper-conscious about that. So now that we've distributed the 3, we have to figure out what to do with expressions like the one we see here in the middle, u to the minus 2 raised to the power 3. What do we do with those exponents to combine them together into a single power of u? What's going to happen here? Multiply. How do we know, by the way, that multiplying these exponents is the right thing to do? Yeah. Under what circumstances do you multiply exponents?
We went over this. U, for example, if it's like minus 6 times another, for say u to negative 3.
Uh-huh.
You add those because there's no parentheses.
You would add them, right, so if I had something different, if I had u to the minus 2 times u to the 3 with separate powers of u multiplied together, under those circumstances, the exponents add. When you multiply powers, you add exponents. But here, we're not multiplying powers, we're raising a power to a power, right? A power of a power. And a power of a power is when we multiply. So there. Multiply these together, get negative 6. And that probably is the most common point of confusion in working with exponents, is answering for yourself the question, should I be adding these exponents together or should I be multiplying these exponents by one another? And anytime it's a power of a power, and one giveaway for that is that you're only writing the base once, you're only writing u once in that example. A power of a power, you multiply the exponents. Whereas when you multiply powers together, the exponents add. The trope that I always like to use to keep that all straight is the arithmetic hierarchy, which isn't showing up the way that I want it to here. Carve out a little bit of space. There we go. That says that whatever we do to the monomial, we do the thing underneath it to the exponent. So if I multiply monomials together, that means that I should be adding the exponents, because that's the thing underneath it. But then that same relationship also holds everywhere else on this diagram. Right? If I raise a monomial to a power, which is what we're doing here, we multiply the exponents. If I divide monomials, I'll subtract exponents, and so on. So keeping that straight is the key to navigating this problem.
V to the third over y, or sorry,
W to the negative 6. What is 3 to the third, by the way?
27.
27. Yeah, 3 times 3 times 3. 9 is a common incorrect answer to that. Okay, and then I have u to the 3, w to the minus 1 sitting out in the front. Okay, so now we've handled all the simplification of raising powers to powers inside of the old original set of parentheses. So now what's the play? How do we go forward from here? Yes and yes. I think you're both right in some way here. So one of the things we could do is we could worry about the fact that some of our exponents are negative right now, right, and switch them to positive. How do you switch a negative exponent to a positive again? Move it. Yeah, either move it from the top part of the fraction to the bottom or vice versa, right, to switch it from negative to positive. We could do that now. I generally prefer to wait on doing that step until the very end of the problem, but you could certainly do it now and you'd be just fine. But I think I'd like to wait on that. And instead, let's suppose that we were just to multiply this rational expression here on the left by this expression over here on the right. What can I combine together to make simpler in that instance? Yeah, we've got some common, what I like to call common factors, factors that are like factors. We have some powers of u that we hopefully can combine and get together to make a single power of u, and we also have some common powers of w that we can combine together and make a single power of w. So now we have to answer that question again. If I'm going to combine u to the minus 6 and u to the 3, what am I going to do to those exponents to combine them? Yeah, here, because we're multiplying these powers together, the exponents add. So how many u's do I end up with in total? U to the minus 6 times u to the positive 3, negative 6 plus 3. Negative 3. So another reason to be careful about signs in an example like this. The v's, well, v's don't have anything to combine with, so I'm just going to leave them. What about the w's? I've got w to the minus 1, I've got w to the minus 6, but my w to the minus 6 lives down in the denominator. So what am I really doing with these powers? Yeah, we could move it up at this point. But yeah, so what I'd rather think about doing is I'm going to slide that power of w over here instead, just to emphasize, where it's really going to combine is with w that's over there on the right. But I'm dividing now this many powers of w by that many powers of w. And when you divide powers, what happens to their exponents? Subtract them. So the number of w's that I have is negative 1 minus negative 6. Talk about perfect place to screw up a sign. This is one of those perfect places. Because what is negative 1 minus negative 6? That would be negative 1 minus 6. Negative 1 minus negative 6. Yeah, it's the same as negative 1 plus positive 6. That's 5. So the number of w's that I end up with, powers of w, is 5. And now I've done all my combining. All my powers of u are together, all my powers of v are together, all my powers of w are together, and the last thing to do is to rewrite the exponents so that they're positive instead of negative. What should I move?
Sorry, we just did one step back.
So if you turn them into each fractions that you then multiplied across, you still have the same final step, which is that we have these common powers of w upstairs and downstairs, which we can combine together because they're dividing one another by subtracting their exponents. -1 minus -6 gives us +5. And the last thing we need to do is just turn that negative exponent into a positive. How do we do it? Flip it. Put it on the bottom. And what is it? What are we flipping? The v has a positive exponent, but the u, yeah, has u to the -3. And when you say flip it, what does that mean? What does that look like?
Oh, you only flip the ones that are negative.
Yes. Only those that have negative exponents give us an opportunity to be rewritten.
V3, W5 over V to the third.
27, v to the third, w to the fifth. And when I move u to the -3 downstairs, it becomes u to the +3.
Really quick, if it helps anybody, if you don't like seeing the negative signs, you can do the same flipping step, but right here. So just flip the signs around, putting u down, the u to the 6 up top, and the w down below. Then you don't have to look at the negative signs at all. You're all done with looking at negatives. It's already taking place. You're only dealing with positive numbers. If it helps.
That's
if it
true.
doesn't, then
Anytime you see a negative exponent, if it helps you, make it positive right away. That's totally fine. That's a matter of personal taste. If you're,
see, I'm looking at negative numbers. So.
yeah, well, I think there's definitely a case to be made for that.